Welcome back, everyone. Welcome to lesson 2. So if you remember last lesson, we learned about parallel lines and transversals and all the rules surrounding them. Today what we're going to do is talk about triangles and the way that we can use those angle rules to make some statements about the nature of a triangle, the fundamental nature of the shape that is a triangle. So the first thing that I want to say is that everything that we talk about this lesson is going to be to do with the alternate rule, that alternate angles are equal. This Z rule that we sometimes call it. So a lot of what we talk about today, in fact pretty much everything, is to do with that one rule. The next thing I want to do is actually draw a triangle. So I'm going to take my ruler and I'm just going to draw any old triangle. It actually doesn't matter what triangle I draw. It can be any triangle at all. So I'm going to be fairly rough with how I draw it. I'm just going to draw, there's my triangle. So now I've got a triangle, three-sided shape, three angles. The next thing I'm going to do is extend these sides. So I'm going to take my bottom side here and extend it out like that. And then I'm going to actually draw a parallel line from the top point, from what we call the apex. Now, I can't tell that that's perfectly parallel because I didn't use a protractor, but we're just going to say that they are for now, because to be honest, while we're doing this little demo here, if it's not perfect, then it doesn't matter too much. The next thing I'm going to do is extend these two sidelines. By the way, while I'm doing this, when I say if it's not perfect, it doesn't matter, it actually does when we're doing it for real, but for the purposes of this demo, we can be a little rough. So there we go. Now I have my triangle, and you can see that what I've done is I've actually created a triangle from two parallel lines and two transversals. And so we can make some statements about these lines. But first of all, like we always do, we have to name our points. So I'm going to name this point A, and I'm going to name this point B, and I'm going to name this point C, and then there's a couple more that I have to name. The next one I have to name is this one out here, and I'm going to call it D, and I have to name this point out here, and I'm going to call it E, and if I quickly think about it, those should be the only points that we have to name. So if we remember our alternate angles rule, we can start finding some alternate angles. For example, here's one, and here's one. This will be angle A, B, C, and this one will be angle B, C, D. So over here, we can write angle A, B, C equals angle B, C, D, because alternate angles are equal. And we can do the same over on the other side. So here's another angle. This is angle B, A, C. Angle back. And it's going to be the same as its alternate angle, which is this one up here, which is angle A, C, E. Angle ace. So angle back equals angle ace, because alternate angles are equal. So those are the first two pieces of information that we need to know. The next thing that we need to remember is that angles that add up to make a straight line equal 180 degrees. So what we know is that angle ABC in here and the angle that's on the outside, which I haven't named, are going to add up to 180. And angle back over here is going to be the same with the one on its outside. They're going to add up to 180 as well. So we can say a few things. First of all, if these two are the same and these two are the same, then the only angle that we need to now find to add up to 180 is this one in the middle. And that's really important because what I've just said is that these three angles add up to 180. So if angle BCD plus angle ACE plus this angle in the middle, which is going to be angle ACB, add up to 180, and we know that angle BCD is the same as angle ABC, and angle ACE is the same as angle BAC, then these three angles, the internal angles of the triangle, must also add up to 180. I'm going to say that again. We know that angle ABC is the same as angle BCD. And we know that angle BAC is the same as angle ACE. And we know that angle BCD and angle ACB and angle ACE all add up to 180. So instead of using this one and this one, we could just as easily use these bottom two, because these two are the same and these two are the same. Which means that angle ABC and angle BAC and angle ACB add up to 180. So we can write that angle ABC plus angle BAC plus angle ACB equal 180 degrees. Now I'm going to introduce a new piece of terminology here, a new symbol, which is this one. Just a little triangle with the angles pointed out. And all that means is that I know that these three angles add up to 180 because the internal angles of a triangle add up to 180. And that is always going to be true. I'm going to write it down here. The internal angles of a triangle always add to 180 degrees. And here's my symbol again. So now, if you're doing some working out and you make a statement like this, these three angles add to 180, instead of saying angle ABC plus angle BAC plus angle ACB equals 180 because the internal angles of a triangle always add to 180, you can just write and then our little triangle. Now, what's cool about this is always going to be true, no matter what triangle I drew. I could have drawn a really long one and I'd still be able to make these statements over here. What I like about this, what I've just drawn, is we call this a mathematical proof. And what a mathematical proof is something very, very solid. It's one of the foundations of the universe in which we live. There is no other way that a triangle can exist except for its angles to add to 180. It's never going to add to 181. It's never going to add to 179. The internal angles of a triangle always add to 180. And this is why. This is why this is a beautiful thing. On paper, right here, we have explained, we have proved a fundamental fact about the very nature of the universe in which we live. And that's a pretty amazing thing if you think about it. So that's actually all that you need to know for lesson number 2. Before I go, however, I would like to point out that there's a little bit of a problem with my working. And that is that you can see my equal signs are kind of all over the shop. In proper working out, I should have equal signs straight below one another every single time. And this is important because it keeps it neat, keeps my working out neat. Unfortunately, I was a little bit messy here because I had judged the amount of space that I had incorrectly. But in future, I'm going to try my hardest, and you should too, to keep your equal signs directly underneath each other. Also pay attention to the little symbols that I use here. These little angles, they look like an L, but they're actually not. They mean an angle. These Z symbols, all my units. The way that I've set up my working is there because mathematicians are lazy. We don't like to have to write a bunch of different words all the time. We like to keep it as simple as possible while maintaining clarity, while being as clear as possible. And you should too. This is really useful because it means that you don't have to write a big paragraph every time you solve a piece of maths. You can just write a couple of letters, a symbol and a number, and be done with it. So this symbology is really useful to learn because it saves yourself a lot of time. If you're ever in an exam and you need to write out a lot of working for a problem-solving question or something, this would be the way to do it. Save yourself some time and some energy. So thank you very much. This is the next video in our series, and the main takeaway from it is that the internal angles of a triangle add up to 180 degrees. Next lesson, lesson 3, we're going to talk about quadrilaterals, four-sided shapes. And so I'll see you then. Good luck.